Hey, good afternoon, everyone, and welcome to another version of Stuff That Works. Today, we're going to focus on two questions, actually, one of two questions that Cobb County asks us to remember every time we prepare a lesson. One, what are we going to do if they don't get it? And two, what do we do if they do get it? That's our focus today. Now, Cobb County's provided a list of strategies, 12, that have great write-ups, great examples, and I encourage you to go find these on the Cobb County site and read them and use them. 12 strategies is a lot, though. So I also, in the last month or so, have been focusing on a book called Advancing Differentiation by Richard Cash. Excellent book, lots of examples. If you have a copy of it around, I encourage you to look at those as well. But when we put together the Cobb County strategies and the strategies from Advancing Differentiation, we get 15 strategies. I don't think it's possible to be successful using 15 total strategies. Two reasons. One, it's an incredible amount of work for you personally. And two, your students need to learn these strategies and you need to instruct them in learning them when they use them the first, second, maybe even third time. So my suggestion to you is to use only 3 or 4 of these strategies, train your students how to use them, and then have them in your toolkit. Here's 3 strategies I use: error analysis, because I'm a math teacher. All right, justify your thinking, and also one that's really fun. What happens if X is a million? Things like that, things that students don't normally think about. But I'm not here to sell you on those 3 strategies. This afternoon, I'm here to sell you on another strategy, 4-square concept map. Now you might be thinking, 4-square concept map, holy cow, this is an old and tired strategy and doesn't really work. Well, let me tell you something. 4-square concept map is a great strategy. In fact, it is the Swiss Army knife of strategies. Now, we're going to spend a little time with a friend of mine, Tiny Elvis. And Tiny Elvis is going to take us through the 4-square organizer. So let's turn it over to Tiny Elvis. There he is. Yeah, there you go. Okay. Round of applause for Tiny Elvis. All right. Again, 4-square organizer, the Swiss Army knife of strategy. So you have your basic 4 squares. First thing I'll point out as a math teacher that these are not squares. And most of the time when you use them, they aren't. They're rectangles. But 4 rectangle organizer doesn't quite have the ring of 4-square organizer. Anyway, it's simple to use. You put a prompt in the upper left corner, and then you give some minimal instructions about what to do in the other 3 brackets. For instance, you ask a student why. Why is something like this? And you ask them to say because in some form and because in another form. And here's a good one, not because. Students are normally taught to think about because, but not necessarily not because. Or if you think about a what example, they can draw an example in a picture, an example in words, but also a non-example. So what things are not like this? Again, students don't normally think of them in that way. Here's another way: fact 1 and fact 2, and show a connection between these two. That's a different connection between fact 1 and fact 2. So you can see already how versatile this is, how it's the Swiss Army knife of strategies. I've used it 3 or 4 different ways already. Here's one that I used just recently in class. So they have to solve an exponential problem, and they have to use an inverse function, and then they have to use a log function to solve it. All right. And notice on the end here, I'm not asking them to tell me the answer. I'm asking them to tell me what's different about those strategies and what's significant about those differences. Again, we're trying to get the students to think kind of out of the box or think differently and in a way that's different than they've been asked to think. Let's think about how this works just in how does this strategy work for differentiating for the gifted students in your class? How does it work? Well, for one thing, we can differentiate by process and product. Notice that the process is, for math anyway, is not a solving process. It's a thinking process. And the product that they come up with is not an answer. It is some thinking about their particular problem. It also adds rigor because it forces them to think in a way they don't think before, use different and alternative strategies. It's also good for either small groups or individuals, depending on the situation and how things are going in your classroom with the lesson that everyone else is using. Here's another way that you might have seen this. It has a prompt in the middle, and it's called the Frayer model. Yes, thank you, Elvis. This is called the Frayer model. All right, there's a prompt in the middle, and it's more focused than the other strategies. You start with a definition in the upper left. You have some characteristics, and then you have examples and non-examples. And it should all hang together. The Frayer model, because it has a name, has a lot of research behind it. But here's a good example. Socked is in the middle. We give a definition of socked, simple past tense of socked. But in the lower left, we have socked. Well, there's another interpretation of socked that you might not have thought about. The upper right one, definitely socked. And then the non-example, here's our Mickey. He is gloved, but not socked. So kids can be creative in these, and you can get some answers that maybe you wouldn't expect. There's a lot of research behind the Frayer model. By providing students a structure to examine words, focusing primarily on contextual meaning and not simply definition, it's an effective way of helping students understand vocabulary at a level beyond defining the words. It pushes learners to learn a more concrete understanding of the meaning of words. This is really important in this effects of mathematical vocabulary instruction for fourth graders. They found that the fourth graders who used the Frayer model understood their math much better than the ones who didn't. And then we have another example, that was 1997, another more recent example, teaching vocabulary using the Frayer model has a significant effect on teaching vocabulary by using a conventional method. All right, so we've seen that this Swiss Army knife of strategies can provoke thinking, stimulate thoughts, engage the brain, and lead to some unboxed thinking, some answers that you might not be aware of or might not have thought of. Students come up with stuff. Or, in the words of our tiny Elvis presenter, let's rock and roll with this strategy. Well, there you have it. The 4-square strategy, the Swiss Army knife of learning strategies. I encourage you to pull it out of your drawer and see what you can do with it. Well, that's all for today, and good teaching.